Welcome back, algebra friends! Today we are going to continue systems of equations. So remember, we started with graphing. That was nice and easy when they were in y equals mx plus b, and, well, they fit on the graph nice and pretty. And then we looked at substitution. Well, substitution is probably one of my favorites, but with substitution we really need one of our variables to already be solved for, or we're going to have to do work before we can start substituting. Well, next up we have what we call elimination. So there are three methods. Again, three methods for solving a systems: graphing, substitution, and elimination. So we need to talk about what is elimination. And well, the word elimination just kind of says it all. It means we're going to eliminate. We are going to add or subtract in order to eliminate one of the variables so that we can then use substitution. So we're going to look here. We have a checklist. The first one is, are the equations lined up? And you're like, lined up? What does that mean? To be lined up, we need to have x over x, y over y, equals over equals, and constant over constant. Or they could be in a different order, but they have to be exactly the same. And we'll look at a couple that aren't, but they have to be lined up or this doesn't work at all. Then we're looking for common coefficients. Common coefficients. Well, if I look at this problem, you see this? I have a 4 and a negative 4. And then I have a 9 and a 7. So you look at the x coefficients and you look at the y coefficients. Well, when I look at the x coefficients, I see that they both have a 4, and that's good. I see that this has the y has a 9 and a 7. Well, those aren't the same, so I really can't use those as they're written. And I don't care about the constants. Remember, I'm trying to eliminate a variable. So we have a common coefficient. We have a 4. And then we need to add or subtract. You're like, what do you mean add or subtract? Remember back, when we used to do this? Yeah, we are literally just going to combine these two using a vertical method. Now I have a 4 and a negative 4. If I have a 4 and a negative 4, am I going to need to add those together or subtract those in order to get them to cancel out? Now I know you're thinking, well, I have a 4 and a negative 4, so technically we are subtracting. But if we just think about the variable here with that coefficient, 4 and negative 4, if I add those together, they make a 0. If I subtract them, that would be 4 minus negative 4. Now that's addition. So 4 and negative 4, if I combine them through addition, so I'm going to add this entire expression to the top one, or the equations together. 4 and negative 4, well, those are going to cancel. That makes 0, right? They're the same. 9 and 7y, I add 9y, 7y. Well, that's 16y. Equals come straight down. Remember, these are all lined up. 11 and 5 makes 16. Now all I have is y. We have eliminated the x. Still solving for y, so I'm just going to divide both sides by 16. And I'm going to have y equals 1. Well, now that I know y, remember, we can go find x using either equation. It doesn't matter which one we use. I'm just going to use the top one. So I have 4x plus 9. Now that y is 1, so times 1 equals 5. So 4x plus 9 equals 5. Two-step equation now. Now I'm just going to subtract the 9 from both sides. And now I have 4x equals negative 4. Divide both sides by 4. Well, x is going to equal, looks like, negative 1. So my solution, remember, solutions are always coordinates. They're always a location in which these two systems overlap each other. They intersect. This solution makes both of them true. Remember, x before y, so negative 1, 1. So take a deep breath, pause, make sure you are kind of thinking all the way through. Make sure you're writing everything out. Second part of this, though, is remember, as mathematicians, you can always check your work. I could plug this coordinate back into both of these and make them true. So negative 1 times 4, that'd be negative 4, plus 9 times positive 1 is 9, negative 4 and 9, yes, that equals 5. And then I would do the same here. I have negative 4 and negative 1. Negative 4 times negative 1 would be a positive 4, plus 7 times 1, and 7 times 1 is 7. Positive 4 plus 7 equals 11. I can prove I'm right before I move on. So if you're working through these and you're like, oh, I think I got it, go check. That way you make sure you're not making any silly mistakes. Okay, let's look at another one. Are the equations lined up? I look, x over x, y over y, equals over equals, constant over constant. That works. That means that I can be looking at these to see how can I combine them? Can I add them or subtract them to make a variable eliminate or drop off? I look at my x first. I have x and 3x. Well, that's a coefficient of 1, right? 1 and 3 are not the same. I look at my y's. In front I would have a 1 and a 1. So 1 and 1, I have a negative and I have a positive. So that's going to work. Those are opposites or additive inverses. So we're just going to add everything up. X and 3x, yep, 4x, negative 1 and positive 1, cancel, keep the equals. 10 and 18, that would add to 28. Now we're going to divide both sides by 4. We know that x is 7. That's only half of what you need, though. You need to go ahead and put that back in. Remember, it doesn't matter which equation you use. Two-step equation here, so subtract your 7. Negative y equals 3. Still not done. That negative is attached to y, so I'm going to divide both sides by negative 1. And y is going to equal negative 3. So our solution is 7, negative 3. Now go ahead and take this information, plug it in, make sure you're correct before you move to your next equation.